Hello.
Hello.
Welcome.
We hope you've been taking care of business
Yeah.
and working overtime.
No.
Workout.
Reading week. We hope that it was restful. We hope that you did something memorable. We hope
Positively memorable.
Positively memorable. We hope that you are okay. And obviously, a massive shout out to those of you who are managing increasing stress as a result of what's happening in Ukraine. Family, friends, loved ones. Canada has the largest population of Ukrainians outside of Ukraine and Russia. And so it is particularly hard-hitting, I guess, for us. And we are following along and doing what we can. And there are things that you can do, including sharing important voices on social media. You can amplify those voices. And if you have money, you can donate money to various causes and charities. Right now, there are some big ones going on. Ryan Reynolds is getting involved.
Look out.
Look out, because dude has some deep pockets.
And as long as your name's not Rob Delaney, getting involved with Ryan Reynolds is probably going to be okay.
It's going to be okay.
Shout out to Deadpool 2.
Yeah. And any questions that you have or anything, we are going to be here after class. If you'd like to talk about things not specifically related to 1070, so would we. So we're happy to do that.
So why did we play BTO?
Why did we play BTO?
Bachman Turner Overdrive.
Bachman. So I happen to really appreciate Randy Bachman. Randy Bachman.
Because of his guitar or because of his radio program?
Because of his smarts. He has a radio program called Vinyl Tap, which is an evening CBC radio program. And the reason why I like it is I did not grow up appreciating music. I have an auditory thing that makes it just difficult for me to appreciate music. But what I really like about Vinyl Tap is that it's like walking around a museum with somebody who knows about art history. He interprets, he provides context, he tells you, he curates his music really well and thoughtfully.
Yep, he's also a real good raconteur. He talks. He was around through a lot of.
He's kind of one of the Forrest Gumps of music, right?
Yeah. He's like,
kind of been
I happened
everywhere.
to be in the room in the background when so and so was talking to so and they came up with the such and such.
That's right.
3-chord Nirvana that we all enjoy today.
Yeah,
and he's also from Winnipeg. And Winnipeg is also a bastion of the Ukrainian-Canadian community. And his mother
is Ukrainian.
Yeah. And escaped just before the Second World War. So,
shout out, Randy Bachman.
And it's a happy birthday.
Oh.
To MPEL02.
Yay.
And your brothers. Which means
Yay.
either, chance event or a jumeau.
Right. One or the other. I also shared the same birthday with my brother, and I know what that's like, and it's not fair. Happy birthday. Wonderful. Okay, good. I think a lot of you are here. There's a few coming in still, and your sheep drawings are delightful. One of you is a sleepy sheep. Most of you are buckethead sheep.
Sleepy sheepy.
Some of you are sleepy sheep number 5. I see it. Really good. I love sheep number 9. I'm not sure if I'm there yet, but I do like the person on their back. I think that's great.
I think sleepy sheep number 9 saw something.
Yeah. Oh, so
it's a due date. It's a due date.
Wonderful. Okay. Good. Okay. Cool. Yeah. Number 1. I think I'm a 1 too. I really needed reading week. Did you?
Oh, you know that I did, but. Did it work? No, I need another one.
Yeah,
I was supposed to write a chapter this week.
You did good.
Yeah, I have 52 figures. Right now it's a picture book.
Yeah. Well, if you take all the captions and instead of make them captions, just make them text.
I'll read it at a conference.
Yeah.
At the next conference. On the next page, you can see the adventure of the little ant going up and down the mountain and freezing or cooking.
Perfect. I like it. Okay. Great. I love your drawings.
No way.
Mine's
not jumeau.
Oh, okay.
Wow.
Okay.
That's cool.
Great. Awesome. Here we go. And I'm going to clear now.
Are we recording?
It. We are recording.
That's good, because people will want to go back to this.
Clear all drawings. There we go.
Clear all drawings.
Okay.
Stay on target.
There's still folks coming in though. I feel well, but we should. Oh no! Here we go. Very important.
Yeah.
Tell them about the foxes, because I think that's great.
Foxes, as Rafi taught us, sleep in the forest. Lions sleep in the den. Yeah, hippos sleep on the mountainside?
No, it's the goats.
So if you don't know, if you haven't been following along, we have several fox den on the University of Guelph campus in the Arboretum and in the Dairy Bush and in the associated kind of areas. And last year, this was a den very near, well, I won't tell you, it's near the Dairy Bush, but it's a real pleasure to be able to share this stuff, these cameras, these trail cameras that we put up near the den. And so this was a set of 4 videos that I was considering entering in a contest last year, of either coordinated fox or crow watching on the bottom, or the clown car. If you've been watching the bottom left video, how many fox have come out of that den? I think it's 15, which is impossible for a single mom on her own. So what we think has happened is that in this particular year, there was a mom and her mom, so a grandmother, so 2 dens, 2 families of relatives, and there, if on the bottom left, you can see, if you squint, there's some oranger kits and some browner kits. The orange ones are probably a week, maybe less, older. They're quite dark when they're very young, almost black, and then they turn orange. And so there's very clearly 2 ages there, and it's so lovely.
I have to admit, I've got like the feels for the one in the top left.
For the stress of the mom.
The mom in the top left going, I am not a cow. Stop milking me.
Yeah.
Wonderful. Yeah.
They are so, it's amazing, because one of the other trends that happens is when those babies come out of the ground and start, this is kind of now their daycare in and around the den entrance. And if you've been, I think on one of them, they very quickly go back underground. I'm not sure if it's one of these ones, but it's
beautiful.
They are as soon as they're being weaned, their mom then takes on chewing ticks and other little bits of blood-sucking arthropods off of them. So there's a lot of active grooming that happens.
Awesome.
Yeah. Anyhow.
Wonderful.
You can scroll through that, and right now this space is probably occupied by 5 skunk. So I think I found the den where they are right now.
Cool.
And
I'm team mouse.
And some students have been out and around and helping me as well. Yeah. There was a student who emailed who in their travels around campus have found 2 potential dens.
Wonderful.
One of them was new to me, and and so need to get more cameras out there.
Cool.
It was great.
Wonderful. I like these videos.
Oh, actually, so the What Does a Fox Say? Watch the videos. It's kind of crazy.
Yep.
There you go. Fox break.
Awesome. Okay, cool. So today we're going to talk about food webs and all of the amazing information that you can get from them. But before that, some homework. Remember, like a long time ago? I know. It's okay.
Everybody does, I'm
yeah.
sure.
If you did your homework, now would be a good time to take that out on your notebook or on a file that you have where you've actually done it. Would be really great. But the homework was to fill in this graph, and then we're going to ask you a polling question. So if we go back to the stuff that we did the week before on density dependent and density independent treatment factors, we'll see how you do, and if like it's just too much, like we need more time, then we'll come back to this on Wednesday. So I'll ask you to graph these lines. If it's just like not happening for you, then we won't take it up right now. We'll do it next time just to give you that time to like spend time thinking about it. I totally get if you haven't done it yet, but let's just see if you did. So we asked you to graph 3 lines. What we'd love for you to do, if you've got those done, is to graph what the density dependent control treatment would look like in red, what an effective density independent control treatment would look like in blue, and what an ineffective density dependent control treatment would look like in green. And again, if you're not having any of it, let's just get to the other stuff, then I will wait a few seconds for your cue and you tell me.
Taking care of business every day.
Or put it in the chat and go, Jacob's like, let's just move on.
Every way. Taking care of business. It's all right. Taking care of business.
Okay.
Working overtime. Right on. I never thought of this as a boom mic. Is this in the shot?
Yeah, cool.
If we're thinking about zombies, shout out to Glenn.
Yeah, poor Glenn.
Poor Glenn.
Okay, awesome. Super.
Although Herschel too.
Yeah. Yep. Okay, sweet. So this is great, and this is true. There are 370 of you in this room, and about 12 lines. So if you haven't done it yet, it's fine. And please, like, walk through the whole thought process again, to really try to you know, kind of learn it and go through it, right? That's the best way to do it. But you are totally correct, those that have shared these lines, and so that's fantastic. So let's just take this Z then. Thanks, Samuel. Yeah, it's a Z. And I'll here, there. Those are my lines. That's my Z. So well done. Really good. That's perfect. Let's clear.
Could the density dependent one be negative too?
Could the yeah, you asked me about this the last time, the whole idea about could the density dependent be negative, and like which, like a negative relationship, an inverse relationship, and I've been trying to think of like a case. So yes, if you know, it's actually more effective on a sparser population. So yes, I just don't know of an example, which is fine, but like yeah, anyway, I've enjoyed thinking about it.
Stuff.
Oh yeah, territorials maybe? Yeah. Okay. Anyway.
Potentially.
Okay.
Territorial zombies.
So what you're what you're looking for is basically evidence that the effectiveness of the treatment is dependent upon the population density. So you want to see it change with population density with your x-axis, right? Cool. So let's take that and then we'll throw the polling question at you. Thanks.
I'm trying to.
There we go. Cool. So we're looking for the statement that is not consistent with this graph. Okay. Just another few seconds. Okay, 10 more seconds. Okay, and poll, share results. So 34% of you were correct. The one that is not consistent with this graph is is C. Treatment A is the best option to eradicate the population. Okay. And if you want, is it okay if I just take a second to go through some of that?
Yeah, of course.
Because I think it's kind of important.
A wide distribution there of
yeah,
hypotheses.
If you don't mind,
it's a good idea.
I'm going to do this quickly.
Buckle
up. But it's being recorded. Okay, so hopefully you can go back and kind of go, oh yeah, okay, maybe that makes sense, or that doesn't make sense. Here's my question, that kind of deal. For sure, it's totally fine. What I'm going to do is just take advantage of these axes to show you a bit of a story. I'm going to write over top of these axes, though. You're
magic. You just made them disappear.
I'm magic. I just made them disappear. Time is going to be here, and population abundance, is going to be here. Okay. So imagine that we have a population of something. Let's say, I mean, let's do zombies because they're awesome. And
or beetles.
Beetles. You want to do beetles? Like biology? Okay. Beetles.
Elves.
No. Okay. So imagine, right? Get your stamps ready because I want you to help me on this one. Imagine that this is a brand new habitat. It's never seen any beetles before. Where on this graph are we going to start with respect to population abundance and time? So we're right at the beginning. Thank you. Perfect. Good. Okay. Now imagine that this population or this species of beetle has like no competition, right? And so they enter this new habitat and things are pretty good. What's the population going to look like? Everybody's going mad. Yeah, it's going to go up. Super good. Oh, Nolan, I think it's you doing that beautiful S-curve. Danielle, you too. Very good. Oh, Rebecca, if you're doing the blue arrows, you're killing it. Yeah, that's super. Okay, so there's going to be this like S-curve. Forgive me if you don't mind. I'm going to delete because I'll
Let's say clear. Delete's a little aggressive.
Yeah. Oh, okay. So this is time. This is population abundance.
Remember.
If somebody wants to fill that in for me, that would be great. So basically what you've said is exactly correct. So the beetles are going to go up, following along this way. Okay? And then they're kicking ass, no competition. But at some point, they're going to reach a plateau. What's this plateau called?
The age of despair?
No.
Throw it in the chat. Put it on the screen.
Yeah, what happened? What do we call this? Rachel, who's doing that. Thank you. Carrying capacity.
Rhymes with schmarrying schmashmashity.
There we go. Carrying capacity. Super good. Okay, now, imagine you don't like these beetles and, yeah, you want to get rid of them. So what you do is you introduce some kind of pesticide that they don't like, that kills them immediately on contact. And imagine that this pesticide works really, really well. So we're going to start out where I've put this like red dot. Show me what's going to happen to the population if it is an effective pesticide. Nice. Ava's like, yep, going all the perfect. Super good. Okay. Is that an independent or dependent treatment? Population density independent or dependent if it goes all the way down to nothing? Ruby's writing it out. Alex is helping. Marissa's agreeing. Independent. Yes, exactly, right? The reason is because if it's a pesticide that you're going to spray over, right, that's an independent mechanism. If it's effective, it's going to eradicate the population, right? If it's not effective, so actually, clear viewers drawing. Ah, look at that.
Look at you.
Imagine it's not effective. What's going to happen from the red dot? Nice, Eric. Good. Or any of you. Yes. Yeah. So Eric is like, it's a little bit effective, but not totally. And then the rest of you are like, it's not effective at all. Really good. Perfect. Yes. Good. Okay. Now, I'm going to clear viewer drawings and imagine we introduce a population density dependent treatment. So I put out like a little bit of food that's poisoned, and the way that it spreads is that one beetle brings a little bit of food to another, and then to another, and then to another, and it's by close contact kind of distribution. And so imagine we do this. It is density dependent. What is going to happen from that point? There's a little bit of disagreement, and I like that. That's really great. Okay, perfect. So, super. Okay, we're going to clear yours, and I'll kind of talk you through it if that's okay, because I see where you're going with this, and you're doing really well. So let's draw this out. So the density dependent, so it's density dependent, right? And say it's effective, okay? So what's going to happen is at the beginning, the population density is the highest because it's at carrying capacity. Life is going to be pretty shitty for them, right? So the population is going to go down. But then what's going to happen to the effectiveness of the population density dependent treatment? It's also going to go down because population abundance and population density is going down, right? So at some point, it's not going to be effective, right? And maybe it's here. Okay. But then, if it's not really effective, what's going to happen? Population's going to go up. It's going to go up. And if the treatment is still there, then at some point that treatment is going to become more effective. And then it's going to oscillate this way as long as the treatment is still there. Okay? So, imagine. Okay. So, if this is carrying capacity with no treatment. What happens to carrying capacity when you introduce a density-dependent treatment factor? Where's carrying capacity now? Yeah, Alex is like, it reaches a new equilibrium. Yeah, Megan's like, right here. Anna is drawing the line. Perfect. Okay. That's what I wanted to show you, if that's okay. It's probably a lot. That's fine. Hopefully it was pretty clear.
I think it's pretty
helpful.
And so consider the end of Shaun of the Dead.
Why?
Because at the end of Shaun of the Dead, the zombies are basically kept. Not for
Are they?
spoilers, but Sean's best friend is in the shed.
Right.
And they play video games together.
Lower carrying capacity.
So I think there's a new character. I think you could probably infer that in the Shaun of the Dead future,
Yeah.
in the Cornetto trilogy, there's a lower carrying capacity.
I like it. Good. Okay. So hopefully that was helpful.
Shout out to Simon Pegg, Nick Frost, and Edgar Wright.
Yeah. Good. Okay. Great. Thank you. That was fun. I'm really grateful for all of your participation. Yeah. Anyway.
Yeah, it's pretty awesome to see those lines go like whappity 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 whap, which is
Amazing.
a specific term.
Okay. So now for something completely different.
So speaking of Shaun of the Dead, how about Antarctica?
Antarctica. So what we want to do is really, really quickly, kind of rapid fire, construct an Antarctic food web. I'm passionate about Antarctica. I love it there. It is also, can we say this?
What's that? The
simplest ecosystem? Like, are there simpler? I don't think so. It's really simple.
The only competitor might be a deep abyssal zone away from thermal vents. So like deep marine systems away.
Okay.
But like in general, particularly terrestrial.
Yeah.
I think there's no competitor. I think this is the
simple
Eurovision champion.
Okay, so our question is, can you look at that and go, yeah, I know what that means? So is Happy Feet still a thing for you? I maybe not. I don't know. But are you familiar with Happy Feet? Is Happy Feet okay? Throw it in the chat. Get ready, because we're going to ask you questions about
Yep,
okay, I saw it.
Enthusiastic yes, or
Yeah, of course. Good. Okay, so we want you to think about Happy Feet, but not Happy Feet 2, because they made gross errors in ecosystem reconstruction.
Which was, if I remember correctly, principally on the IMDb database and the Rotten Tomatoes. The major criticism of the film was their gross deviation from food system ecology of Antarctica.
Okay, So what we want you to do is to think about all of the elements of the ecosystem from Happy Feet. And you can write all over the slide. You can throw them in the chat.
Yep.
And we want you to like just connect with your inner Happy Feet. What was in those ecosystems? What was there?
Oh, just because you were 4. I'm sure you remember. It's in there.
Come on!
What was in the Happy Feet ecosystem? Music.
Ice, good. Penguins, good.
Come on.
Cold, very good. Water, excellent. What else? Seals. Yeah. Couple of types of seals. Do you know the types?
So
Penguins.
many different species of penguin.
Yeah. Plastic. Yep. You're right.
Somebody,
that was there.
wasn't there a shrimp?
There
Yes!
were. Kind of. Fish. Snow.
Fish
sea
and
lions.
sea lion.
Gulls. Very good.
Humans.
Humans. Aquatic life. Icebergs. Thank you. Macaroni penguins, because they're hilarious. They're also pretty badass. Like, they have attitudes. Happy Feet was there. Yes. Good. Fish. Birds. Great. I think... Oh, we're missing the massive mammals of the oceans. What are we... Where we go? Tigers. Yeah, tiger seal. It's actually a leopard seal, but that's fine. Very good. Okay.
Mammals. It's a mammal
Whales.
mixture.
Ah, the whales were underneath
Yes.
our video feed. There, the whales. Okay.
Cryptic whales. Just like
So
those orca are
cryptic,
cryptic
right?
species.
Oh. Okay.
The birds. The birds.
Don't forget the birds. The birds, the skua, right, is this fantastic seabird because it's
nasty.
like what an eagle would be if it was a seabird.
Yeah.
It's got like that hooked beak. They're amazing.
I think
Okay.
it's also a good swear word. If you're in like polite company where you can't swear, if you put a little bit of
a little bit of skua. Okay, awesome. So, if we were face to face, we would be doing this in a very active, probably really embarrassing kind of a game, but
this is fun.
this is better. Okay, so penguins, right? Krill are the shrimp. So Will and Bill Krill. We have the orcas that are throwing around macaroni penguins. We have leopard seals. We have the skuas, these badass seabirds, the elephant seals, the baleen whales, the jellyfish, and let's also make this the fish because there weren't actually any vertebrate fish that were featured in the Antarctic in Happy Feet. I know, it's killing me too. And ice and water, super good. And then this one up here in the very top is going to represent our phytoplankton because they are really important. So they get trapped in the ice, and then there's these gorgeous sort of marble green type icebergs as a result of the phytoplankton that's in them. It's spectacular.
I want to say something about jellies before we leave today.
Okay. So please go ahead and let's use your lines in any way you want to make some food web connections to all of these things. So what is eating what or living where or feeding on what? Let's just kind of put a whole bunch of lines in there and see if we can identify some patterns.
I like the arrows.
It's good. Nice. One thing that you'll note in food web depictions is that there's a bit of a disagreement on which way the arrows flow. So what you do in order to figure out who eats who, especially like down at the bottom where you may not actually know, is just go up to the top where you have your like your head top predators and go, yeah, okay, so they're, you know, obviously krill are not eating them, they are eating krill, and then just look at where the arrow is pointing and you'll know whether it's, you know, is so-and-so eating so-and-so or is someone being eaten by so-and-so. It can be a bit confusing that way. Okay. Taking a look at this, do you see any species that are like really getting beat up? Are there any? Yeah, thank you. Good. Okay. Will and Bill. Poor Will and Bill krill, right? So there are some species, obviously, that are sort of serve as nodes or these like kind of busy areas on the food web. And I'm reluctant to say the word keystone species because we don't use that word anymore. But if you've heard it before, so Smith does, don't use it. Because every species is important. And if we sort of, and keystone species tend to have quite a bit of human bias too. Some of them are defined based on their economic importance rather than their actual importance biologically within the system. So there's a whole bunch of reasons to not use that term.
It's certainly a term that has been misused.
Yeah.
Its original description is quite elegant.
Cool. So
and it's about...
We'll just call it busy places on the food web.
Super important species.
Yeah. Okay, so keystone species are not a thing, but there are some species that do have more connections. They serve as a bit of a hub within the food system, right? And so we can make all sorts of like inferences about those species. And we can also make inferences about those that have fewer nodes or fewer connections to things, right? So for example, what could we infer about the population size of krill? What's the population abundance? Is it huge or is it small? Based on the number of connections that it has to, Jared's like huge, Anna's big, yeah, huge, good, right? If it's supporting that many predators, it's gonna be a big population. Right? Especially these like massive species that have lots of energetic needs in terms of absolute energy, right? Good. Okay. So we can talk about that, right? So we can make inferences too about like if we remove one of these predators, what might happen to that population. If we remove the entire population of krill, what might happen to all of these things? We can start to kind of understand a little bit about it. It's not just a figure that shows you who eats who. It tells you so much more, right? Is that okay? Do you want to add anything here?
I want to come back to Robert Payne and keystone species, but let's go ahead.
Okay. There we go. Okay. So let's kind of simplify a little bit and say, imagine that this is the Antarctic Food Web, and it's actually not that far off, right? I'll show you what like a textbook figure looks like in a minute, but just to kind of show you. So Will and Bill are pretty important, right? They're connected to like most things. So there are some interesting challenges in Antarctica. And Antarctica, if there ever was a world park, right? Just like there's national parks, it would be Antarctica, in that there is an Antarctic Treaty in order to preserve and conserve the environment. Of course, there are some bad acting countries that come in and try to steal resources and all of that stuff. And krill actually is one of the resources that is highly sought after for pet food and all sorts of other things. We don't consume it as humans normally because it has a toxic level of fluoride. But you can strip it of fluoride, and of course this will probably be an alternative source of protein sometime in the future. So imagine, thank you, Ava, yes, and question mark, you'd think, right? But actually, the amount of penguin feeding that the leopard seal actually does is surprisingly small. The vast majority of their diet is krill. And they do go after penguins, especially as the young ones are going into the water for the first time. And there is a sex difference. I think it's females that feed on them more so, on penguins more so. Most of their diet though is krill and fish. But no, you're right. There should be an arrow there for sure. Okay. Okay. So imagine we remove krill, right? The question is there going to be a massive collapse if we remove all of the krill? Kind of probably, but imagine that, we remove it as a major source of food for all of these predators. You could then imagine that there would be some kind of reshuffling, right? Some kind of like pressure increase on some other source of food, especially in those things that do have these diverse diets, right? Like, for example, what else is feeding on other things? So there's skuas that are also feeding on krill, but also on penguins and other sources of food, right? So you could imagine that there would be a little bit of a reshuffling to maybe put more pressure on fish as well as some of the other invertebrates that are in the ecosystem. And then, that might happen sort of within the first 10 years or so, sort of short term. And then over time, we would start to see these extinctions of things that really can no longer be sustained by the population abundance of the alternative source of food, right? If there's no replacement of it, then things could get even, more simple within the ecosystem. And this is what this is from a textbook, what an Antarctic ecosystem actually does look like. So we've done a pretty good job at building up more or less what it looks like from Happy Feet.
So go back for a second.
Okay.
Because one of the things that is always missing here is the fact that there's biases. We've talked about biases before in terms of plotting.
Oh yeah, this is good.
And graphing and all sorts of things. But biases come into play when we're estimating food webs, because more often than not, we don't know about these lines for many things because we see them, we infer them. Sometimes there's crazy BBC video of different mammals eating other large birds or mammals eating mammals, fine. But as soon as you get into the little things, we infer who's eaten whom, often by doing the glorious work of sorting through gut contents or sorting through poop. And what preserves in poop? Our kids would love this.
They would totally have
What
the
preserves
answer.
in poop? It's throw it in the chat, but spoiler alert, it's hard parts. And so we have a bias to our understanding of who eats whom as to who has hard parts. And the thing is, in marine systems, the vast majority, the vast volume of life has no hard parts at all. It's jellies. It's cnidarians and ctenophores, so jellyfish and comb jellies. And up until maybe 20 years ago, we thought of jellies as trophic dead ends. That if energy went into that system, it basically, I don't know what marine food web ecologists thought, but we didn't kind of make connections because we didn't know who was there. But now we can, in addition to sorting through the poop, we can sequence it. And so that's my pipette. I'm pulling it out, I'm putting it into the sequencer, and then an answer. And what we find out is everything eats jellies. They're not a dead end at all. And maybe this makes intuitive sense. It's kind of one of those things where it's like, well, if they're just like we talked about, as you talked about with the krill, if they're abundant, there's something's eating them.
Yeah.
And jellies are abundant, everything's eating them. And so this is kind of an underappreciated, not that this is not wrong, but it's missing. And this is one of the biases in food web biology, is our understanding of nodes are really caused by our understanding of the species biology and the intimate species biology for most of the things on the planet. You have to figure out, because we don't know it yet.
Cool. Thanks. Okay.
Yes, jellies are why animals eat plastic bags. That's so if you're concerned about sea turtles, or if you want a way to change your understanding of sea turtles, Google image search the inside of a sea turtle's mouth. It is a nightmare, and it's the last thing a jellyfish sees, and it's why many sea turtles die by eating plastic bags.
That's right. Good. Okay.
All right.
Quick question for you.
Thank you. It's out of my system. Trophic dead ends. Abundant trophic dead ends. As if such a thing could exist. Off topic, but is Dr. Smith the one in the pre-lecture reading interview? Do I look that bad now?
Yes.
A
much younger version. Much younger. Cool. Great. Just a few more seconds. You're all clicking in.
Somebody just Googled it. Oh my God. Yeah. It puts it different to switch kind of animated films to Nemo and the surfer dude.
Yeah.
Yeah, it puts a different slant on that.
Okay, sharing results. Yes. So, it totally depends, right? But predominantly what you would expect, at least at the beginning, is that the niches of the other species in the ecosystem are going to change if they can, right? And so then it really comes down to which ones can change, which ones can't. the individual biology, right? But it would be reasonable to expect that there would be some adjustment in niche as a result before a collapse.
It pleases me how many people have Googled image searched the inside of a sea turtle's mouth.
Yeah.
And so this it's simple, right?
No.
Until we start figuring out that the players in the play there's a lot of them. This is not a Waiting for Godot where there's like the playlist has 2 characters. This is a Dickensian like, and then Fruppelwerp and Thipperthop and blah, blah, blah. This is a long character list. And so even when we think in the top frame, we thought we knew who the players in the play were. No, the bottom one, it's even more complicated.
Yeah. And this is where, your thoughts and your philosophy on what a species is come into play. This is where, your understanding of the cryptic species and the diversity of things come into play.
That's what happened. Actually, that's a figure of mine there. So these were species that on the top morphologically, and then after in the bottom, we barcoded them to figure out that there were more things there than we thought.
Yep.
And so there's more nodes that we had not appreciated.
Yep. Wonderful. Okay. And can I skip that one?
Yeah, you can.
Yeah, is it okay?
I already had my invertebrate outburst. So that was
we're going to limit ourselves to one.
That was my invertebrate outburst from last week.
Okay, so let's bring it to Canada and to the Grand Banks off of the coast of Newfoundland
and Labrador. You have to say it like that.
That's right.
Welcome, Newfoundland. And Labrador.
And the Newfoundlanders would say that it wasn't Newfoundland that joined Canada in 1949.
Canada joined Newfoundland.
That's right. Okay. So this is the ecosystem in the waters off of Newfoundland and Labrador. And it's complex, you can see. And so there's like a lot going on with the seabirds, and there's a lot going on with the fish. That's a classic figure.
This is in the primary literature.
And the only reason it's there is to overwhelm the reader. So if you are overwhelmed, then it has achieved its job.
Right? And it's largely done pre-computers.
Yeah, somebody drew those.
Yeah.
Which is amazing. Yeah. Okay, but at the center of it all, right here, I'm putting a red circle around it. I hope you can see. Is cod. Cod is kind of right in the middle of all of the busyness. So it is one of those big hubs with lots of connections, right? And we want to just end off today by telling you the story of cod and the relationship that it has in Canada, in Canadian history. Because cod were totally doing great up until a whole bunch of folks from Europe decided that they would like to colonize North America, in large part because of its natural resources, in large part because of its cod, right? So they come in thinking that all of these things are freely available to them to use in the way that they were using them in Europe, not recognizing that completely disrespecting the fact that there were people already here using natural resources in very different ways for very different reasons. And cod was one of the big drivers of the colonization of North America, in particular of Canada, of the northern part of North America. There were Canadian heritage moments written about it, talking about how the cod were so dense. This is like a super, kind of super joke of my time. The cod were so dense that it delayed the progress of our ships, I think was the quote from the heritage moment in Canada. But anyway, yeah, there were a lot of cod, okay? That created this colonial history of fishing, largely based in Newfoundland and Labrador. And things economically were pretty good. Environmentally, not so much. And culturally, also not so much. But economically, things were pretty good for a while, for a whole bunch of families and a whole bunch of companies that were largely responsible for fishing and distributing cod all around the world. And we can take a look at it just with respect to the catches, the historical catches. Things were great up until the 70s, and then people started to talk a little bit.
Disco!
Yeah. And then, everything seemed to be okay for a little while, so no one really talked about it again. And then they say out of the blue, although there were lots of warning signs and lots of people, folks, scientists saying, hey, we better watch out, but there were lots of politics as well. That were going on, such that there was this massive crash in the cod economy, which was absolutely devastating for folks that were living in Newfoundland and Labrador. Indigenous folks as well as settler folks that were part of the cod fishery. This was not an easy time for them. There were all sorts of challenges economically, devastating stories happening. If any of you are, part of a family that was affected by this, then you know very well the level of disruption that it had on Canadian families. And there weren't many cod left. And the stories going around in the media at the time were really putting the blame on external factors. It wasn't a good idea to blame the economic system, right? Because then we might actually have to change it for more sustainable practices. And the government may actually have to invest in supporting families to do that. Instead, we all just kind of went with the narrative that it was the gray seals that were eating all of the cod. So this was the narrative that the gray seals were coming in, they were taking all of the cod. The gray seal population was increasing, so there was evidence to support this particular observation, and that was not leaving much cod for the fishers. And so then the result of that was a cull that was introduced in order to decrease the population of gray seals, right? And you could argue whether that was density dependent or independent. You can go kind of both ways on that one, but it did have an impact on the gray seal population. But what it did not have was an impact on the cod population. And that's because hopefully you've recognized that food webs and ecosystems are nuanced and complex and wonderful. And also little known by some of us. And so the actual story of what happened is quite a bit different. So the story was that we were totally overfishing and taking way more than is sustainable. And that as a result of that, in response to that, gray seals, the species, changed its niche slightly and started focusing on smaller fish. So they shifted their diet away from cod because cod populations were dwindling, and they started to adapt and change their diets to these smaller fish. Now, of course, that in this particular context reduced competition and allowed for the gray seal population to increase. So it increased the carrying capacity of gray seals. And it's a very different story that we now know to be true with more research and more science backing it up. But you can see how the observation of the increase in the gray seal population in association with some absolutely terrible economic conditions, governments not willing to invest in sustainable change, led to that first narrative being the preferred narrative. So let's take that uber complex cod ecosystem with the food web and all of that stuff and simplify it a little bit to this. This is not simple, but let's just simplify it a little bit because we're going to throw a homework question at you for Wednesday. So imagine then that this is the Grand Banks ecosystem, and it's complex for a few reasons. Take a look and you can see worms. Everything's a worm, right? Okay, so but there are more invertebrates on this one. Like, you're happier? Okay. So take a look here, because larval cod, juvenile cod, and adult cod are represented in 3 separate places, right? So what does that mean about their niche? What can we say about the niche of cod if they are represented in different places on a food web based on their age class? What can we say? Like, what's a true statement about the niche of cod relative to this food web?
Throw it in the chat.
Throw it in the chat.
Throw it on the screen. Niche changes with age.
Yeah, super good.
You got it.
Niche changes with age. Multiple. Very good.
Yep.
Yes, multiple niches that change throughout the lifetime. And that's kind of possible, right, for many things that are, served basically as food for things, and as they grow up, they become predators, right?
It's actually super common.
Yeah.
For most life in the world. You think about butterflies and caterpillars.
Yeah.
They're different parts for most of life. at different life history stages, you eat very differently.
And then, of course, someone's noticed that they are still prey at every stage, and you're right.
Oh, I thought that was advice.
No.
Pray at every stage.
Prey at every stage.
Hello, Stag. You're so beautiful.
Yeah, totally. So it's complex, right? And so here's your homework question, and with that, we'll say goodbye. The homework question is, based on this simplified food web, what could happen if 25 years after the collapse of the cod population, we released millions of adult, juvenile, or larval cod? So kind of go through those scenarios about what might happen to the populations of other species if we release each of these three.
Model those scenarios.
Yeah, and then for homework take up next time on Wednesday, we'll do a polling question with just one of those. So get ready, and we will see you next time. Take care.
Be safe, be kind.